Alright, testing. Section 4. Section 4, General Electric Locomotive Dash 7 Series, Instruction, Rotating Equipment, Introduction, Traction, Alternator, Description, Data, Lubrication, Inspection, Maintenance Procedure, Auxiliary Generator, Exciter, Description, Data, Special Tools, Equipment, Lubrication, Inspection, Communicator, Resurfacing, Traction motor, description, data, inspection, lubrication, replacing axle linings on the locomotive, resurfacing commutator in the locomotive, commutator maintenance, description, construction, surface condition, resurface of the communicator. The accessory is a brief description of the electrical rotating apparatus, locomotive such as the traction alternator, auxiliary generator, exciter and the traction motor for the detailed analysis for the applicable maintenance from that annual furnished with the locomotive. Figure 4.1 shows the traction alternator with auxiliary generator, GY27 and GY27 exciter. Okay, description: the GTA 11 traction alternator is a salient pole, three ways, Y-connected alternator current generated with conversion of mechanical energy locomotive, the diesel engine for the electrical power required for locomotive propulsion. The AC output for the alternator is converted to DC. This means the rectifier panel used by the power supply with the DC traction motors. The GTA 11 alternator is a single bearing separately with excited machine, which is directly connected to the diesel engine. The engine crankshaft supports the approximately half the weight of the alternator rotor, and the other half is supported with the outboard end by the means of the roller bearing, which is splash lubricated from the axle auxiliary drive gear unit. Excitation unit is supplied by the exciter with the figure 4 with the amount of the non-driven alternator through the auxiliary drive of the gear system, also shown in figure 4 with its auxiliary generator which supplied with the power for the control system. A simplified schematic diagram is shown on the GTA 11 alternator shown in figure 4 too. Alright, your type. The GTA 11. Classification: 10 pole, 3 phase, Y connected AC generator. Rotation: phase collecting ring and counterclockwise. Brushes. Quantity per machine: 6. Type of spear: 524. Minimum length of the which brush becomes inoperative: inches, 1 3/16 of an inch. Brush arm pressure: new brush, pounds, 4 1/4 to 4 3/4. Brush holder clearance and collector ring in inches: 332 to 1/8 of an inch. Lubrication: auxiliary drive gear case capacity initial filling approximately pints 5. Lubricating: low film types SAE 40 engine lube, GED6B 18B. Lubrication: the alternator roller bearing and splash lubricated for the auxiliary drive gear with no other lubrication is required. Check the oil level of the auxiliary drive gear unit. That means for the dipstick located with the lower right hand side of the gear case, facing collector end between the exciter and the alternator frame head. If the engine is shut down, read the oil level on the side of the dipstick marked with the generator stop. If the engine is idling, read the oil level on the side of the dipstick marked with the generator running, maintaining the oil level between the full and added marks from the dipstick. Or figure 4.2 shows the schematic diagram for the GTA alternator, the exciter, the relay, the alternator field, the slip ring in the brush, and slip ring in the brush for the field, alternator field from the rotor, and then the stator has AC/DC rectifier panel with 3-phase winding. And the general inspection schedule for the alternator should conform with the inspection schedule established for the overall locomotive that may be modified as required for the actual operating experience. The following information is offered with the general inspection guide, which calls for the attention to what should be inspected, what to look when making the inspection. If the inspection results with the call for the corrective maintenance to be performed, the procedure for the carrying out the maintenance are covered in the maintenance procedure section. General: make a visual inspection for the evidence loose or missing auxiliary gear case mounting bolts which hold the electrical connection box cover and the loose, damaged, missing latches and inspection covers. Also check for oil leakage from the auxiliary drive gear unit and around the auxiliary mounting flanges. Make sure the gear unit and its oil drain plug is tight. Brushes. Brushes. Inspect the wear and replace the brushes which have the reach of the minimum permissible length of 1 3/16 of an inch, which may be too short to run until the next inspection. Check with the brushes. Measure the top of the brush clip and the center of the curved surface for the contact with the collector ring. Look at the number 2. Look for chip broken brushes loose and frayed pigtails. Place such brushes as necessary. Alright, we missed the part. It said, caution: do not overfill the gear case. Overfilling may result in the oil being drained from the alternator being onto the collector rings and windings, causing serious operating difficulty. Drain the gear case once a year or after 180,000 miles of operation, whichever occurs first. Refill the SAA 40 engine lube oil, specification D6B 118B. And I guess that's because I didn't back out of the page. Let's go to 100% then. Figure 4-3, corrected position of the brush tail pigtail terminals. Alright, show for the pigtail terminal and the brush pigtail terminal. Make sure for the pigtail terminals are positioned and shown in figure 4-3 with the pigtail for the terminal screw with the type with the brush for the up and down several times with the brush hole with the release of the carbon dust in the form matter with the carbon waves which may prevent the free movement of the brush holders. Check the loose or broken bent overheated pressure arms. Overheating will cause it to become discolored and result with improper brush arm pressure. Be sure that the thumb loop of the coil brush pressure swing is positioned shown in figure 4-4. Inspection brush holder mounting. Make sure that the studs are tight and check the brush holder to collect a ring of 3/32 inch to 1/8 of an inch adjust as necessary. Collector rings. Wipe off the insulation between the rings and cling dry cloth. Inspect the evidence of the physical damage. Check for surface of the collecting rings, evidence of the discolorization, etching, grooving, threading, or other signs of the distress that may recover. Require corrective action to help determine the need for such action. And figure 4-4 shows the brush holder assembly, the pigtail terminal screw, thumb loop, brush pressure spring, brush pressure arm, brush pigtail, brush box, brush holder stud, key. Following information is offered in inspection guide. Ideally, the collector ring surface has been uniform chocolate brown color, but be free with the etching and threading with the grooving. Conditions ever encounters and surface, however, they include oil vapors, adverse humidity conditions, and air contamination of various kinds that add to difficulty to maintain the ideal collector ring surface. If dark spots appear on the ring surface, they will be likely to uniform brush spacing. The spots later in the grayish color, accompanied by the etching of the color, turn to a grayish color, accompanied by the etching of the color ring surface. If appropriate action is taken at this point, soon the dark spots appear with no later than the first evidence of the grayish etched condition. Most more serious problems can be avoided later by removing the distressed area with the brush, cedar, and stone, as described under the maintenance procedures section. With the corrective action, severe arcing and grooving of the collector ring with the resultant rapid brush wear, following quickly until the grooving extends over the 180 degrees or more with the ring surface requires the ring to ground in order to be removed from the burned spots, grooving and the restored ring surface to true circle. Bus rings and field leads. Check for cracked and frayed damage insulation, field coil connection straps, and inspect the insulation of the evidence for the cracked and physical damage that may require corrective action. Maintenance procedures, resurfacing collector rings. When inspecting the review of the corrective maintenance required with the resurface of the collector rings by one of the following two methods depending on the severity of the burn spot of the grooving. The brush or cedar stone. When engine shut down, remove all the collector ring brush with the tape of the seat stone onto the end of the stick for the use of the shown figure 4 or 5. Warning, protection from the end of the rotating field, leave insufficient clearance above the rear inboard collector ring for the use of the handheld stone to avoid serious injury. Resurface the rings with the stone tap to the end of the stick. Alright, 3. Start the engine with the idle speed. Apply the ensure enough pressure to seat the cedar stone to produce the cutting action required to remove the dark and the burn spot. Let down the engine for the inspect the ring surface of the further stone that's required to repeat steps 2 and 3. Continue doing this until the ring surface is clean. Warning, when using the compressed air for cleaning of the environmental potential hazards for the personnel of the immediately areas created to prevent air physical injury or flying debris and observe all railroad and OSHA safety regulations. Figure 4-5 shows the resurfacing collector rings with a brushed cedar stone. Shows the bus ring, the cedar stone, the wooden stick, and the field lead, and the brush holder stud. 6. When the engine is idle speed, clean the collector ring with the surface by using cleaning direct compressed air. Shut down the engine to reinstall the brushes. 8. Sand brushes to remove the metal. They may have to transfer the collector ring from the brush contact surface. Use the strip of 2-inch by 24-inch long fine grit sandpaper for their operation. Warning, when using compressed air for the cleaning of the purpose of environmental potential hazardous personnel immediately area of the created to prevent physical injury with flying debris to preserve all the railroad OSHA safety regulations. 9. Blow out the carbon dust from the cleaning dry compressed air. Collector ring grinder. Alright, figure 4-6 for the collector ring grinder drawing. When the engine shut down, move all the brushes from the brush holder. Remove the 2 collector brush rings with the field lead with attached so they will interfere with the grinder installation with the grinding operation. Remove the 2 brushes number 5 and 6 from the brush holder yoke located with the right side of the alternator facing the collector and mark or label the stud. Reduce the possibility of reassembling them in the incorrect position. Test the grinder without stone installed to the brush yoke in the number 6 brush holder position, meaning with the number 6 brush holder and stud cap screw in shown figure 4-7 in the grinder mounting bracket is designed so that once the attached to the yoke, no further alignment is required. 5. Adjust the radial feed to stop the preventing of the grinder way of the damage of the collector ring if the stone wears too short. If install the stone with the right hand inboard support and dummy stone in the left hand outboard support, clamp the stone at the proper angle to permit the full travel of the stone across the ring surface. If the burning of the groove is severe, start with a medium grade stone and change to the fine grade stone for finished operation. Note, grinding only one ring at a time. Final ring diameters need not to be the same. Figure 4-6 show the collector ring grinder. Okay, one is your, you got your collector ring brush surface, end of brush holder, brush and yoke, maximum radial travel, the carriage limited by stop, SCR, rotation view from the collector ring end, frame face, collector rings, and 1 is the grinder, 2 is the MTG bracket, and 3 is the hex bolt, 4 is the lock washer, 5 is the universal joint, 6 is the spacer, 7 is the adapter, 8 is an adapter, 9 is a flex hand, 10 is the stone, 11 is the stone, and 12 is the hex bolt. To start the engine with a running at idle speed, feed with the radial inward with the means of the feed with the screw until the stone makes the contact with the collector ring surface the transverse stone back of the forth across the ring surface the means with the traverse knob, alternately continuing feeding of the stone inwardly slowly as way of the transverse ring. Periodically shut down engine check progress for the grinding operation. Repeat 7, 8, 9 as many times as necessary to remove for the burn spots and grooving. Chain with the fine grade stone for the finishing operation. When the grinding operation completed with the engine shut down, remove the grinding fixture. Be careful not to nick or scratch the rings. Warning, when using compressed air with a cleaner purposive, the environmental potential hazard if the personal immediate air created to prevent the physical injury with the flying debris. Observe all railroad OSHA safety regulations. 12. Restart the engine and the alternator running at an engine idle speed. Blow out the alternator with a dry compressed air. Extract the air so that it removes the grinding dust with the stator windings and field coils. 13. Shut down the engine and reinstall the brush holder stud with the original position. 14. Caution. Failure to install the brush holder stud in the correct position will result in the short circuiting of the collector rings when the excitation is applied. 14. Reinstall the bus rings and field leads. Step 4-7, setup for the grinder collector rings. You have the dummy stone, the grinder stone, flexible shaft, clamp, brush holder, yoke, universal joint, collector ring, radial feed, transverse knob, bus ring, and field lead. 15. Reinstall the brush removed from the surfacing operation. Install the new ones if necessary. 16. If the brush is removed from the resurfacing operation or reused, then remove the metal which may have transverse for the collector ring to the brusher with the contact surface. Use the strip of the fine grit sandpaper 2 inches by 4 but wide by 24 inches long for the operation. Installing new brushes. Caution. When installing a new brush with the G, the recommended grade, do not mix brush grades. Mixing with the brush grades for the same alternator or changing to another grade can seriously affect the collector ring surface film and result in short brush life. Install new brushes shown in figure 4-4. Insert the brushes into the holder with the pigtail connection on the side farthest away from the pigtail terminal screws. 2. Position the pigtail terminal onto the terminal screw so that the terminal is parallel to the brush pressure arm. 3. Tighten the terminal screw and latch the brush pressure spring. Alright, seating the new brushes. Because the new brushes are already contoured with the collector ring, it is necessary to seat them whether they are first to install. Simply install them and described previously as they already ready for operation. Alright, adjusting brush holder clearance. Maintain clearance between the brush holder and the collector rings at 33/32 to 1/8 of an inch. If the clearance is not within the range, readjust the brushes as follows. Remove the brush holder, loosen the cap screw located with the brush holder yoke. 3. Place the firm fiberboard shim with the proper thickness between the bottom of the brush holder with the collector ring. 4. Remove the brush holder down against the fiberboard shim and tighten the brush holder's cap screw. 5. Remove the fiberboard shim and replace the brush and the holder. Make sure that the pigtail terminal screw is tight with the pigtail is correct in the position shown in figure 4-3. Reverse brush polarity. To increase the expensiveness of the collector ring of the brush, periodically reserve the polarity of the brushes by interchanging the 2 exciter leads inside of the alternator connection box over the brush holder. Because of the condition would adversely affect the collector ring with the brush life vary widely with the brush polarity. Reversal should be made with every 6 months until the operating experience indicates that the satisfactory wear rates can be obtained by the reverse polarity less frequency. frequently. Sorry. High potential testing. Customary to apply an annual Interstate Commerce Commission high and potential testing complete locomotive power circuit where they include the all traction motor, traction alternator, auxiliary locomotive wiring, associated switching apparatus. For the procedure to be followed within this making the test, precautions to be taken to protect the equipment and personnel referred to the appropriate section in the overall locomotive maintenance manual. Auxiliary generator exciter. Description: the GY27 auxiliary generator exciter is force ventilated, shunt wheel wounded, and DC machine. The GY27 located at the 4 o'clock position of the traction alternator. The figure 4.8 is used the auxiliary generator to supply regulated 75 volt DC power to the control equipment light when the charge of the battery. GY27 at 8 o'clock position is used to an exciter to control the field current with the traction alternator. Both having crack windings, and they are two starting the diesel 2 models are the same except for the arrangement of the commutator coverage of the external ventilation connections. Principal parts: auxiliary generators, exciter for the armature, assembly, communicator pinion, end bearings, and brush holder field coils, and a magnet frame. The accelerator generators are mounted on the traction alternator gearbox. The drive gear mounted on the traction alternator shaft extension meshes with the pinion gear on the auxiliary generator exciter shaft to drive each accelerator generator exciter machine. Type: the GY27, rotation clockwise, maximum speed 2900 RPMs, full speed 2400 RPMs. Type 4.8 shows the type GY27 mounted on a traction alternator, typical with a generator and exciter. Your classification: 4-pole communicating pole, force ventilated shunt wound DC generator. Nominal rating 12 kilowatts, 75 volts at 8,500 RPMs, 51 kilowatts, 250 volts at 2,400 RPMs. Resistance at 20 degrees Celsius ohms. Armature 0.0229, shunt field 11.05, commuting field 0.00872, starting field 0.00665. Brush grit data, grade GTE 583 type duplex with the rubber pad, pressure in ounces 43 to 53, size in inches, half inch by 1 inch by 2 inch, minimum length which the brush becomes an operative 1 inch, brush holder clearance and communicator 6/10 to 1/10 of an 600 to 1/10 of an inch. Polar bores average. Exciting poles in inches 9.844. Communicating poles in inches 10.098. Communicator data type archbound. Side mica thickness nominal inches 0.022. Grooving depth 0.047. Saw width 0.024. Diameter new inches 8. Minimum permissible 7.5. Grease capacity bearing commuter end at 3 ounces, 3 1/8 of an ounce. Lubrication GED6 AC4. Pinion end no grease required. Splash lubricated. Weight in pounds 695. Alright, warning: electrical shock can cause serious fatal injury. To avoid such injury, personnel should take the observe the proper precautions during the high potential testing. Special tools and equipment. The following items are required to maintain, repair, overhaul auxiliary generator exciter: the communicator grinder and the resurfacing stones. Lubrication: the pin end and bearing lubricated by the oil splash traction alternator gearbox. Maintain the oil level in the gearbox between high and add marks on the dipstick. Periodically spark the CE bearing as follows. Remove the bearing cap and examine the old grease and of the evidence of steel chip that would be indicated the bearing damage. Repack the bearing cap approximately 2 ounces for the D6A2C4 grease. Replace for the bearing cap inspection. Inspect the brushes to be sure that they are not worn with the minimum length chipped or broken. Replace the worn, damaged brushes. Always replace other and same brush holders, since longer brushes are probably defective and do not share load equally. Caution: when replacing brushes, use the GE recommended grade. Mixing with the brushes grade with the same machine, changing the brush with another grade is not recommended, will seriously affect the communication surface film, communicator, and brush life. 2. Inspect the brush holder for the damage from burning and arcing. Check for the damage pressure, springing or level the replacing parts. If necessary, inspect the condition of the communicator. Be sure that it has a smooth, polished surface, clean, and resurface with the necessary C-section communicator resurfacing. Inspect all leads connection. Be sure that the connections are tight, and be sure the insulation resistance of the armature and field coil of the mega ohmmeter. Communicator resurfacing. When the communicator becomes worn or grooved, the bearing it may be resurfaced the communicator grounded without moving the machine from the locomotive or the armature for the machine. Rotating the armature zone bearing the resurface the communicator is done with the communicator grinder assembly part 88436113 G3 and stones listed in the special tools and equipment section. Resurfacing on locomotive. Warning: the environmental potential hazard for the personnel within immediately area created with the resurfacing to prevent physical injury or flying debris. Observe all railroad and OSHA safety regulations. Or remove any of the old dirt from the exposed insulation surface around the communicator using an approved method. Remove the 4 o'clock brush holder assembly and the A1 connection strap of the generator. Figure 4 with the 2 o'clock brush holder assembly on the exciter. Lift all the other brushes off on the machine being surfaced and install the communicator grind with the auxiliary generator exciter as follows in Figure 4 and 9. Assemble the grinder with the mountain bracket with a 2 3/8 to 16th and 1 3/8 of an inch hex bolt lock washer. B. Bolt this assembly of the machine where the brush holder. Remove the key end of the bracket with the key wave at the end of the frame. Then insert the 5/8 of 11 by 1 1/2 hex bolt inches from the frame with a flat washer underhead. Screw the hex bolt into the hole with the bracket and tighten. C. Install the 2 resurfacing stones on the grinder. Space them far enough for the part to cover the entire width of the communicator surface. When the carriage is moved on from side to side from the small communicator, use only the finished grade stones. D. Adjust the holder on the bracket to each zone travels parallel to the surface of the communicator. Adjust the slightly loosen the 2 3/8 of an inch 16 hex bolts. Check with the inserting the feeler gauge between the surface of the communicator, each stone, and each of the travel along with the communicator. The check should be made with the unworn section of the communicator at the both ends between the bullet brush path. After adjustments, back the stones away from the communicator. Tighten the 2 rounding bolts. Place the locomotive reverse handle in the opposition. Check the have the generator field breaker in the open position as no current will pass through the machine being resurfaced. The engine can be started by the cranking of the one machine only. Alright, figure 1-9 shows your communicator grinder installed on the GY27 machine. 1 is your traversing handle. 2 is the feed handle. 3 is the resurfacing stones. 4 is the grinder, and then 5 is the bracket, and then 6 is the cap screw with the washer. Start the engine, let it run for the idle until the run smooth. The operation may be performed immediately after the locomotive returns its run while the engine is still warm. Advance the stones to take a light cut across the communicator surface to check alignment before proceeding with the operation. Stone should cut approximately the same amount of the front end, the rise of the communicator where the brush paths are not worn and surface in the amount of the cut is not the same. Readjust the grinder until the cut is approximately even with the both ends of the communicator. Traverse the grinders advance the units until the communicator is clean. Begin with the light pressure for the increase no more than necessary. Do not take too deep of a cut. This will result in an excessive amount of the copper being dragged over the edge of the communicator bar. If possible, the vacuum cleaning of the device to collect the copper and brace the dust during grinding operation. Make a light finishing cut without changing the feed. Transverse the communicator several times to obtain a good smooth finish. 9. Shut down the engine. Remove the grinder from the auxiliary machine. Using the engraving tool, remove the ragged edges of the communicator bars. Finish with the copper which have been dragged over the slots. If necessary, undercut the slot mica between the segments of the 24,000th of an inch thick saw. Clean the communicator slot. Remove the mica with the grind and the dust off with a stiff nylon bristle brush. Add a new paintbrush or a stencil brush with the bristle cut short for added stiffness to satisfactory. Warning: when using compressed air for the cleaning of the purpose of the environmental potential hazard of the personnel immediately area created to prevent the physical injury of the outlying debris. Observe all of the railroad and OSHA safety regulations. Start the engine, run it at idle, thoroughly blow the communicator interior of the machine while the dry compressed air. Remove all the copper filling for the dust to the point in the communicator. Polish the communicator with a fine solid sandpaper. Shut down the engine with the measure for the communicator. Run out with the dial indicator mounted to the frame. The indicator should have the sensitivity of 50 divisions to 1,000th of an inch. Of smaller from 1 revolution of the pointer. Maximum allowable to run out after its one stone is 1,000 inch. Replace with the brush holder. Assembly. Remove the one connection strap. If it was removed, replace the brushes necessary for the GE recommended grade. Or your traction motor. The GE752 traction motor figure 410 is a 4-pole communicating pipe series wound DC motor designed for locomotive propulsion. Normal function is to convert the electrical energy supplied by the traction generator into the mechanical power for driving the locomotive wheels. The traction motor is coupled to the locomotive axle through the reduction gear housings housed in the gear case. The gear case is attached with the traction motor surrounded with the pinion gear, but the gear case excludes the dirt and moisture hold with the necessary gear lubricants. The locomotive is equipped with dynamic braking used for the traction motor generator to retard the rate of the travel to descending with the grades and slow down the train. Type the GE752, maximum permissible speed 2445, resistance 25 degrees Celsius, average ohms 0.01002, excitation field 00555, communicating field 0.00592, brush data 10 pounds, 10 to 12, size duplex in inches 3/4 by 2 1/4 by 2 inches long, maximum length in which the width of the brush becomes operative, 1 3/4 of an inch, brush holder clearance communicator 1/16 to 3/32 of an inch, side mica thickness 6/10 of an inch, growing 6/100 of an inch, groove depth 3/64 to 5/64, diameter new communicator inches 16 5/8 of an inch, minimum permissible 5 and 15 and 13 15 inches 3/8 of an inch, riser width minimum permissible inches 5/8 of an inch. Pole bearers nominal measure for the center of the poles, exciting poles in inches 19.64, communicating poles 19.97, bearing assembled diametrical clearance armature bearings communicator ends 0.017 to 0.057, pinion end 0.025 to 0.008, axle bearings minimum new inches 14,000 of an inch, maximum worn inches 60,000 of an inch. End play, armature bearings new inches is 5,000 of an inch to 14,000 of an inch. Axle bearing new lining inch in inches 1/16, worn 1/8 of an inch. Max wear per lining flange inches 5/16 of an inch. Impedance of the field circuits. Measured before assembly armature of 60 AC cycles, AC to hot field coils only. Exciting field 24 amps, maximum volts 14.8, minimum volts 13.7. Communicator field 24 amps, volts 9, maximum 9.6, minimum 8.3. Measure the brush limited armature assembled 60 AC. Exciting fields 24 amps, 17.6 max, 15.6 minimum. Communication field 24 amps, 12.6 maximum, 11.0 minimum. Weights motor with a pinion pounds 7,000, armature pounds 2,100 and 2,170. Or inspect the communicator, wipe off the string with the string band with the communicator, strip with the must free with the copper tube that has smooth polish, strip with the clean, the restrip for the communicator when necessary. The brush hold mechanism must operate properly, terminals must be tight and insulator clean. Inspect the brush for physical appearance with the amount of the wear, replace any with the which or clipped, chipped, unbroken, worn near the minimum length with 1/32 of an inch. Brush must move freely and in the holders and free the dirt, carbon dust, and other foreign material. Caution: when replacing brush with a DE, recommended the grade with mixing with the brush grade within the same with the machine with changing the brush with another grade could seriously affect the communication surface of the film and the brush life. Check with the adjust the spring pressure, inspect with the clearance between the bottom of the brush holder and the communicator support. See data section. Examine the armature field coil with the cracked and charred, broken insulation. See field coil connections if the tight. Examine the 6. Examine the flash ring for the damage. Keep the flash ring clean and free of the paint insulation. 7. Measure the insulation resistance from the mega ohm meter reading with the 1 mega ohm. This is indicated with the further inspection to determine the insulation failure to express if the moisture should be made with the correct same with the low mega ohm reading with the placing the box in the surface. Warning: when using the compressed air for the cleaning purpose of the environmental potential hazard to personnel immediately air created to prevent the physical injury, flying debris. Observe all the railroad OSHA safety regulations. 8. Blow out the motor thoroughly when the both direction with the dry compressed air. 9. Clean the string band and paint it with the insulation with the A varnish A15B17A if needed. Figure 411 shows the measuring end play, shows the use of the feeler gauge, the safe clearance, the go, no go, and this symbol and no enter too much when no go enters and go. Alright, caution: do not apply the insulation varnish over the dirt or other contamination below provided with the current leakage path as well with the other varnishes. Measure end play with the motor with the axle diametrical clearance with the axle line. See the data section for the permissible limits of the wear. Measure all the following. To measure the end play, move the motor toward the gear bearing between the nose suspension truck bolster. Measure the end play lateral clearance through the drain hole in the axle flange dust guard located in the communicator end. Use the feeler air go, no go. gauge as shown in Figure 411. If the gear lubricating is frozen, the pinion gear of the motor cannot be barred sideways, clear at each end of the motor with the gear. The total lateral clearance clear at the pinion end and can be measured between the gear hub and the axle lining flange, inserting the feeler through the drain hole with the gear case seal. Or another method of measuring end play is to clamp the indicator communicator end with the axle cap at the point rested against the wheel in Figure 412. Force the motor as far as it will go one way all along the axle and set the indicator at 0. Force the motor in the other direction as far as it will go. Read the lateral clearance of the end play with the clearance equal to the exceed of the permissible amount. Install new linings. See Figure 413 for the method of measuring diametrical clearance of the axle linings. Alright, Figure 412 shows the using the dial indicator to measure the end play, show the wheel, the motor frame, the clearance to be measured, the dust guard, and the method of mounting the dial indicator for the measure lateral clearance without moving the flange dust guard. Alright, removing the felt wick lubricators, examine them following the defects. Wear of an excessive quarter-inch Figure 414. Burned hardened wick surfaces with no longer absorbent. See damaged wick or wick holders. Figure 413 shows the measuring diametrical clearance over the linings. Alright, shows the lateral clearance and the diametrical clearance and the dust guard. The dust guard is drawn out to the picture side on the left. The relief does not get stuck here or the feeler gauge. Figure 414 shows the condemning limit for the felt with lubricator. Replace lubricator when worn to quarter-inch or dimension. Lubrication armature bearing. The roller bearings are packed at the time motor assembly with the ball bearing grease. The GE spec D6A2C4. No excess provided with additional grease during the operation of the motor between overall periods. Axle bearing. The motor is equipped with a large oil capacity axle cap having the felt wick lubricators, the oil, and axle bend bearings. When the pressure for the water of the dirt over the other contaminants suspect with examination oil recommended, this can be done readily with drawn out with a sample at the bottom of the oil well with a piece of the glass tubing. If examined, change the use of the oil. Use the AR spec M90656 oil may maintain a level at the bottom of the filler cap opening gear with the spur gearing lubricated with a heavier gear compound with the GE spec D50. E8C for the 10 gear case. Caution: never permit the gears to run dry. The result will excessive wear of the gear and pinion teeth. Caution: never overfill the gear case. Doing so could cause the gear compound to enter the armature bearing and cause the bearing failure. Replace the axle linings on the locomotive. Replace the axle lining with removing the motor without removing the motor from the truck. Replace the truck over the pit and drain oil over the axle cap with the remove of the flange dust guard. The axle caps and the axle dust guard replaced as fouls. Use the pinch bar to force the motor toward the communicator end so the clear end of the maintain with the easy removal of the pin ending and the lining. Remove the 3 gear case mounting bolts. 3. Loosen the bolts and the hole in the 2 sections of the gear case together. Allow the bottom half to drop about 1 inch. 4. Insert the 2 3/4 inch pieces of the wood between them and the gear case halves. 1 piece at each end to hold them apart. 5. Lift the motor weight of the axle supporting the axle side of the motor with the jacks to the free of the inner axle lining forward motor away from the axle using the jimmy bar. 6. Reset pinch bar against the inner flange over the wheel. Apply enough leverage against the gear case to raise it freely with from the axle line with the rolls for the axle lining out. Move the inner lining, rotating it away from the key around the top of the axle chief. Check the journal for the robustness. Install the new lining by rotating the inner half of the into the position over the top of the axle. 8. Install the outer half of the new lining with the position and piston end and reassemble the axle gear cap after giving it in thorough cleaning. No, axle caps are machined with a magnet frame. They are not interchangeable though. Their motors. Each cap is stamped with the serial number over the frame with which was originally masked. The axle cap must also be assembled to the motor frame, having corresponding serial number. Never use the shims between the frame of the magnet frame and the axle cap. This will destroy the clamping effect. The result of loose lines. The axle lines will, when correctly assembled, are tight and clamped between the magnet frame and the axle caps to prevent the movement and with the wear of the outside diameter of the linings. Axle cap bolts are drawn down until the face of the cap and the face of the magnet frame are a tight fit. 9. Tighten the axle caps to about 800 pound-a-foot torque, lubricating the axle cap with the white lead with the oil before the tightening. Lock the bolt with a wire through the bolt heads to replace the dust guards. Fill the caps with 4 quarts of AR Spec M90656 car oil. Replace the gear case. Add 12 pounds of GE Spec D850 E8C lubrication. Resurfacing communicator in the locomotive. 1. Place the locomotive over the cut out the air brake and cut out the air brakes of the truck, requiring the motor maintenance. B. Block the wheel for the axle being worked on the locomotive cannot move. C. Set the air brakes on the other locomotive trucks. Axle equipped with rolling bearings may be raised with placing the wooden block between the pedestal tie bars for the general block for the axle being rotated. Block should be thick enough to fill the space with the jack end of the truck until the wear clears over the rail. Raise all the brush except for the two located 180 degrees apart, which will be used to run the traction motor. If the diesel engine is to be run, insert the baffle into the motor. Air duct dust will not be blown about. Warning: an environmental potential hazard personnel to immediate air with the correction with the resurfacing preventing physical energy by the flying debris. Observe all railroad OSHA safety regulations. Install the grinder part A837582G1 in the bottom of the communicator open end location suspension side in a safe place that will allow the most of the grinding dust to fall out. See figure 415. The grinding assembly consists of the Medjit grinder with the K88287008G1 or part 100X371 mounting bracket part 884314 P6 resurfacing stones part 88244492 P8. Various cap screw and set screws are indicated with the figure 416. Install the grinders as follows. Move the grinder mounting bracket, the 4 cap screws, figure 416. Remove the cover on the bottom of the inspection hole of the suspension side. C. Install the grinder motor by bolting it into the cover bolt hole. The 2 cap screws, lock washer 4 and 5, provide with the fixture mace for the mounting brackets will be on the outside of the frame. Place the 2 jam nuts at 9 and the set of screws 8 with the screws on the tap holes and the corners on the base of the mounting bracket. These adjusting positions of the grinder will respect the communicator. Install the medium grade resurfacing stone for the grinder for figure 415. 415 show the Medjit communicator grinder installing the GE752 motor. Here figure 416 shows the communicator grinder. Communicator grinder part 1. Number 2 is the mounting bracket. 3 is the resurfacing stone. 4 is your cap screw, 5 lock washer, 6 cap screws, 7 lock washers, 8 set screw, 9 jam nut. F. After the stones installed with the traverse grinder with the one end of the communicator, check for the clearance between the communicator and commutator surface of the one end is one stone with the feeler gauge. Traverse grinder with the other end of the commutator. Check for the clearance under the same stone, but the clearance should be the same. Both ends of the clearance different. Adjusting the mounting with the bracket, meaning with the set screws until the clearance at the same both ends. When the clearance at the same time are the same, tighten the jam nuts 9 on the set screw with the maintain adjusting while the grinding. Turn the feed control of the back stones away from the field from the communicator while the motor is being started. Connect the motor source of the control power to the drive at the speed at 1,000 to 1,500 RPMs. The power can be obtained with the outside surface of the power of the locomotive power plant. Figure 417 shows the diagram connection to the run with the traction motor from the welding set. You have your motor armature and the traction motor field series, FF, AA, FF, and armature DC welder generator set. Disconnect the motor leads with the locomotive wiring and connect the motor with the series motor with the outside with the power set to 3 to 5 kilowatts at a 100 volt welding set. If the outside with the power set to supply to you with the C figure 417. The motor can also be run from the diesel electric locomotive power plant with the wheels blocked except for the connected with the motor to work on. But the motor can be run with the stoning with the communicator without distributing the locomotive connections. Play with the throttle handle with the first operating position. Current required to run the motor is slow. No damage will result with the block stationary motor through the current flow. Warning: to protect the personnel with the physical harm following the safety precautions of Tier 2, the block locomotive wheels is to protect the locomotive from being moving during the grinding of the operation. Make the block permanent positively secure. The second person must be sure of the power control station ready to shut off the power in case of emergency during grinding operation. The grinding operator should wear goggles in the dust mask guard with the grinding or blowing out with the communicator. 7. Apply with the traction motor. Apply power to the traction motor gradually, bring the speed to 100 RPMs to 1,500 RPMs. 1,000 RPMs to 1,500 RPMs. The fixture of the back of the further along with the communicator with a slow advancing stone with the forward communicator surface. Make extreme caution advanced stone to obtain the fine cut and to avoid shatter. Note, use the medium stone for the rough cuts, and for finishing the fine stones, rowing the motor in the opposite direction. 9. Ground the commutator until the uniformly smooth surface is obtained, with all the flat spots have been removed, and do not remove the copper, more copper than necessary. 10. After the final cut, transverse the stones back to the further longitude without changing the feed until there is no cutting action. 11. Remove the power from the motor. Remove the grinding fixture. 12. Scrape the slots of the removed bars to remove the proper projection mica fins and copper whiskers. Warning, when using compressed air cleaning, the purpose of the environmental potential have the personal in the immediate air with creative to prevent physical injury with flying debris. Observe all railroad and OSHA safety regulations. 13. Run the motor again at 1,000 RPMs. Power for the communicator at 00 fine or sandpaper. Blow it out for the communicator interior of the motor with the dry compressed air. Hold the end of the hose about 1 to 2 inches from the communicator surface. Sweep longitudinally. Blow away with the copper chip with the loose mica. 14. Remove the power and make the necessary mechanical electrical changes to play for the motor back and surface and locomotive series on the locomotive. 15. Install new brushes. Note, do not grind the communicator to the depth of where the mica undercuts has been removed. Commutator maintenance. Description. Communicator figure 418 virtual part of every DC motor generator, therefore then deserves the very best care. The fact of the communicator usually showing signs of the distress being probable trouble actually occurs is a big help to the maintainer. If you can recognize these signs, know when to do, you can often correct the trouble becomes a series. A commutator has 3 functions. It provides required sliding electrical contact between the fixed brush of the moving armature to apply electrical energy to the machine. Figure 418 shows the cutaway section of the commutator, starting with the cap, the mica cone insulation, the mica shell insulation, the shell, the mica cone insulation, the armature coil conductors, the risers, the brush surfaces, and the copper segment bar, and the mica plate insulation Teflon creepage band. It acts as a reversing switch. 2. It acts as a reversing switch as the end of the armature cools pass with the brush position. The commutator switches from one circle to the other, where the current is flowing with the opposite direction. Thus all the current heads of the current flowing through the proper direction at all times. It also brings the voltage to each of the armature coil and the circle of the brush surface the voltage up in the bar bush between the brush with the result of the total operated voltage machine appear for the brushes. Alright, construction. The communicator figure 418 formed of the alternator copper segment, the mica plate with the copper segments that are often called the bars, so hereafter in the publication we will use the term bars instead of segments. The mica plate physically separated the electrical insulation bars provided with the arch pressure of the essential commutator stability. They place for the undercut and below the commutator surface to prevent interference with the sliding of the action brush to the surface of the commutator. The bars are wedge-shaped from the form of the cylinder when assembled. Each of the bar has a riser at one end to make the armature coil connections. The bars are held positional by the clamping action with a steel cap bolts and a steel shell in the figure 419. 419 shows the arc-bound communicator assembly. 1. The communicator shell. 2. The communicator cap. 3. The commutator segment. 4. The shell insulation. 6. 5. The cone insulation. 6. The cone insulation. 7. The cap screw hex socket. And 8. The creepage band. Mica stones countered to fit between the shell and the cap insulate the bars from grounding armature. The Teflon creepage band applied with the exposed cone and the insulation protect the mica with the damage presence. The smooth creepage surface is easy to clean and keep it clean. Surface conditions. Communicator cannot work properly unless the brush is made with a good electrical content attack. It requires a smooth, polished, cylindrical surface that runs true with its center. Surface film. The successful operation of all DC machines, but depending on the maintaining properly film with the surface of the commutator of the figure 420 with the film of the carbon graphite, copper oxide, and water vapor is deposited on the commutator surface by electrochemical actions formed by the wiping action with the brusher against the commutator by normal current flow between the brushes and the commutator. The important its important maintenance for the proper communicator surface of the film cannot be overemphasized. The film established with a properly maintained good brush performance, roofs the brush and communicator wear, and the satisfactory communication, no destructive sparking is assured. The changes in colors from copper to the deep brown or chocolate should give the no cause for worry as long as they surface is smooth and have been polished, glossy appearance. Figure 420 shows the good communicator film on the uniform color. The color pattern. The term indicates the only color of the communicator bars that is not uniform with a definite pattern exists. The pattern is almost always related to the arrangement coils and the armature slots. It is self-conditioned, no signs of damage. The color pattern shows up several sequences, figure 421 and 422. As long as there is no definite pattern around the whole communicator can be considered. A check surface damage should not be made. The scheduled communicator inspection periods. If no damage, no further action is required. Match marking, etching, and flat spots. The following conditions indicate the discolorization and/or etching of the communicator bars, but in varying degrees. Possible cause of the etching discolorization include excessive load on the machine, electrical adjustment off, such as a worn shim behind the communicating pole's wrong interpole gap. 3. Wrong brush gauge. 4. Uneven rough communicator surface. 5. Contaminated atmosphere. 6. Incorrect brush spacing. And 7. Incorrect brush shift. Figure 421 shows 1 light, 2 dark, 3 coil per slot color pattern. Figure 422 shows 1 dark, 2 light, 3 coil per slot color pattern. The best way to overcome these conditions is to determine the cause of the make necessary corrections, and if the damage has not progressed too far, the may clear it itself once the cause has been eliminated. It is determined that some of the research of the communicator is necessary should be done sparingly. Marking. The conditions appear opaque, the dark surface and the black deposit on the bars, usually at the trailing edge with no etching with the corrosion with the copper underneath. Check the condition quickly and use the common principle of the eraser to remove the deposit. Examine the copper surface of the roughness and the pitting. If none is seen, then the condition of the marking, which can readily be removed with a canvas cloth. See figure 413. Or 423, sorry. Bar surfacing etching. The condition of the gives the appearance of the subtle marking with the pencil erasers uncovers the pitting and eroded the bar surface of the condition result of the arcing between the brush of the communicator copper communicator bars. The etching with usually visible with the naked eye when marking them is removed. Figure 424 and 425. Figure 423 shows the communicator film with a pencil erase to show the smooth copper surface and underneath. Figure 424 shows a heavy etching 2 coil per slot communicator. Bar corner etching. When this condition prevails, the corner of the bar eroding, leaving chamfered corner, but little no evidence of the marking of the bar surface etching. Figure 425 shows the irregular filming and etching caused by rough communicator. The bar coning etching may be the best seen with the holding the tight light source at that angle with the reflective light with the chamfer at the corner of the eye. Flat spots. Etching is not directed and progresses too far with the flat spot will develop. The flat spots may also develop from the mechanical disturbance such as the vibration from the defective bearing. As a rule, however, the flat spots result from fairly correct some of the faulty conditions with the reverse indicated within burn bars figure 426. Threading. Threading is a communicator surface of the condition showing the circumferential curve of the communicator threading as a result of the abrasive electrochemical action of the brushes. In light, threading grooves may be just barely apparent when the surface of filming the color disturbed and different. In heavy threading, a rippled surface can be felt with if you rub the fingernail along the surface of the bar in figure 427 and 428. The brush faces where to fit the grooves when the communicator shifted due with the armature end play with the brushes are lifted out with the groove. The contact between the brush and the communicator disturbed sparking occurs. Communication is disrupted. Figure 426 shows the flash spots of the communicator, but it also shows flashover damage. Figure 427 shows heavy threading of the communicator. Possible cause of the threading include low current density in the brush of the machine that are not heavily loaded, debris, dirt, and other foreign matter material embedded in the face of the brush. 3. Microflakes copper embedded in the brush faces, and 4. Wrong brush grade. Figure 428 shows the illustration of threading of the communicator surface. Shows the brush and the communicator bar with the threaded surface. The end of the cause of the slight over the shift of the bar, and in the circle they say brush face forced out of the grooves into the bar. Alright, copper drag. Under certain conditions, the copper is dragged over the trailer edge of the communicator bars have the appearance of the metal, small metal flakes with the feathers. Copper drag the copper, the particles, the copper oxide, contaminate contaminants that do not bind firmly with the surface of the communicator. Communicator rotates the brush is shoved the small flake with the material absorbed into the communicator slots. Decrease the distance between the bar of the arc of the form of the brush, and that can be then more easily covered over the adjacent brush, resulting in flashover. Copper drag should not be confused with this corner etching figure 429 and 430. Possible cause of the copper drag causes the copper drag over the contaminated after copper embedded with the floor brush faces or spot brushes, wrong brush grade, excessive vibration, low current density. A temporary solution with the copper drag to clean with the communicator, occasionally with a light brush steel stone, is drag and progressive too far, and the slots may be racked and cleaned. Alright, bending is the surface defect of the form bands around the communicator with the surface that have been partially completed. Remove the bands are made quite narrow and not to be confused with threading. They may be extended over the sizing with a percentage of the brush path in figure 431, for example, the 30 band. 429 shows the copper drag with the trailing edge of the communicator bars. 430 shows the illustration copper drag, a brush for communicator bar, trailing edge, rotation, mica plate. Possible cause of the damage and banding include brush film with heavy film tears of the surface from the surface of one brush to the wrong grade. 3 hard spots on brush. Bending on the can be corrected with a hard stoning after the cause has been eliminated. Eccentricity. Even though the communicator surface is smooth, it can be run off the center. The common fault is usually the easiest of all the surface variation brushes to follow. The simple raise and fall with the holders, which each revolution, however the speed goes up, the eccentric motion becomes faster. Finally, the brush begins to break when contact gradually burn with the communicator surface. As this continues, the burning causes still further surface destruction. Figure 432. 431 shows the example of banding. 432 example of the eccentric communicator exaggerated from the purpose of the illustration, the communicator center and the bearing center. Okay, possible causes of eccentricity include bent shaft bearings are not running true, the communicator machine with a bad shaft center with a distortion causing wide temperature change with a high speed 5, and offset coupling and single bearing traction generators. Determine the cause of the eccentricity reserved for the communicator using the originally mounted on a grinding fixture. The eccentricity cannot be corrected by hand stoning. Surfaces. Sometimes the sharpest step of the curve of the communicator surface may be covered with the blow or the bump of the communicator through the change of the surface level that may be very small, and even a heavy spring load that will keep the brush in contact with the depressed bar with the brush. It may skip jump from the higher level of the or if the rotation is reversed, the step strikes the brush and kicks them away from the surface. This causes the sparking, followed by electrical erosion and flat space spots on the surface of the communicator at high speed. This kick may be hard enough to shatter the brush. See figure 433. Figure 433 shows the effect of the depressed bars and reversal rotation. Show the brush bounces and brush shatters. Possible cause surface breaks include bumping the communicator surface during handling, striking the communicator with a heavy tool, reach over the commutator with the originally mounted grinding fixture of the remove of the surface break. Alright, high bars. If the motor armature does not rotate while the motor power is applied with the communicator bar under the brush will overheat as expansion will cause the bars to rise above the adjacent bar with the armature rotate. With the high bars kick with the brush with the term of the arc point with the communicator surface. If the condition is not corrected, the brush may shatter and flash over. The coal could occur with see figure 434 and 435. Figure 434 shows the example of the soft communicator brush which has lifted at the high speed. Figure 435 shows the effect of high bars of the brushes. A. High bars each for the brush position resulting from the installing. B. Brush action resulting from the high bars. In severe cases, the bars temperature may rise high enough to enable the copper to destroy the binding with the mica plate. What happens to flake with the mica that will shift them from the pressure of the air with reduce the clamping action with the bar and enable the bars differently with the normal bars being loose with the level lifts and armature speed. Annealed bars can be detected with a scalerscope or some equivalent means. Sometimes they can be spotted by the discoloration of the bar ends of the outside of the brush track. High mica refers to the high relationship between the surface of the mica plate and the surface of the communicator bar. The figure 436A for the correct relationship. In normal use, the surface of the communicator gradually worn down, the copper is worn away, the depth of the undercut of the slot is reduced until the edge of the mica plates are so even that slightly higher than the surface of the communicator. The figure 436B. At this point, mica is called high mica. High mica can be a result with either normal electromechanical wear failure, undercut of the mica, and after resurfacing operation. Alright, 436A, show the mica properly undercut. 436B, show the high mica copper worn down. 436C, show the feather edge of the mica incorrectly cut. Our feather edge mica cut resulting in incorrect undercutting of the high mica of the figure 4C, which leave the feather edge mica with the communicator surface. Either from the high mica that disrupts the process of the communication, this term with increase of the wear of the communicator bar of the brush is exposed more mica and further disrupts the communication. Alright, flashover damage. Any condition that defect that causes the arcing of the surface of the communicator must be regarded as the potential cause of flashover. The arcing becomes serve enough of the surrounding air chain to conduct with the gas, so they allow for the power to slip over between the brushes and in the flashover. The flashover the communicator final protest against neglect and abuse. The evidence of the machine is flashover that will be found in the form of the copper splatter on the surface of the ends of the communicator bars on the brush holder and nearby insulation on the frame is shown in figure 437. If flashover occurs, clean the communicator. If the Teflon creepage band and the brush holders, examine these parts for the damage and check the condition of the brush faces. Repair the plates and parts necessary damage. Figure 437 shows the equipment badly damaged by flashover. Resurfacing the commutator. A warning, an environmental potential hazard personnel that the immediately area created by the resurfacing can prevent physical injury of flying debris. Observe all railroad on OSHA safety regulations. Commutator troubles may often be corrected by resurfacing the name given in the process of the restore of the true cylindrical polished surface of the communicator. Polishing of the communicator surface is merely smudged, and you can clean it with the polishing with a canvas. That is not sufficient. Only, or if you with the communicator slightly rough crocus cloth with a fine 4 to 0 sandpaper that may be used. This should be mounted with a wooden block curved and fit the surface of the communicator, shown in figure 438. Caution: never use emery cloth on the communicator. The abrasive particles not only scratch the surface, but they also conduct the enlargement between the communicator segments. These leads to short circuits. Alright, stoning. If the communicator surface is mildly grooved with the edge of the burn with only a small amount of the copper, it has to be removed with the correct defect. With a hand stone is made with a suitable. The stone should have a surface of curve to the fit with the communicator. Also have a long enough bridge for the defect with the remove the other stone with the bridge right in it, and the defect with the knowing nothing. The corrected length of the stone will usually limited to the space between the brush holder. There is not enough space for the brush holder should be removed to make the room large stone. For a large stone, figure 439. Figure 438 shows the fine grade sandpaper on the shaped wooden block. Shows the sandpaper wood screw on the and washer on the wood shaped commutator. 439. Proper use of the handstone. The span on the contact, the flat spot, and the handstone. The handstoning will not correct any without a running communicator. Fairly difficult operating should be performed in knowledgeable, skilled personnel. Undercutting. The communicator has been resurfaced to check for the depth of the undercut of the mica between the bar of the undercutting necessary should be done carefully with a proper tool. The correct side of the tool must have the sharp edge for the cut of the mica freely. Dual blade and saw produce the small crack of the mica that which the dirt and moisture may find in its way the breakdown insulation between the communicator bars. Some of the common mistakes of the shown figure 440. Avoid the mistakes. Refer to the device instruction book for the slot width over the depth dimension. Figure 440's common mistakes are undercutting the mica between the communicator ends. A. The mica is properly undercut. B. The undercutting tool is narrow and leaving the fine one inside of the slot. C. The undercutting tool very narrow, leaving fines on both sides of the slot. That was C. D. Slot improperly index part of the bar cut away and fin mica left. E. Too wide part of the bar cut away. 5. Undercutting F. Undercutting too shallow surface life with a shortened. G. Undercutting too deep pocket collects carbon and copper dust, short circuiting the barbers. And slot raking and racking and brushing. Resurfacing operation usually leave the copper particles and slipper the edge of the communicator bar within slots. They may be removed before the machine is placed and surface as they cause a flash open for the brush with a stiff nylon bristle piece of fiberboard space. Special tool grounded to fit slot with the figure 441B, C, and clean the slots thoroughly. Slot racking tool figure 41A. Break sharp edge of the bar. If resurfacing has produced the considerable copper drag of the bar's edge of the V-shaped slot racking tool should be removed the fins and ragged edges from the bars. Insert the point of the tools with the slot on so the side of the tools will scrap the edge of the bar on each side of the slot with the tool is dragged along the slot. After the slot has been cleaned, it may be necessary to use fine sandpaper with a corrosive cloth to remove the small burrs or slivers from the edge of the bars. Do not use an emery cloth. Figure 441 cleaning communicator slots. Show the screwdriver blade on tool set with the bar not grounded at 60 degree angle for the breaking of slot, 60-degree angle, the 1/32 of an inch radius, side view, 3/16 of an inch by 3/16 of an inch. B, cleaning out the slot in the inner brush path, and then cleaning out the slot on the outer brush path. And that completes section 4. Section 4 of the Rotating Equipment General GE Series 7 locomotive.